easiest way to think about bearing capacity is as supply and demand. The structure delivers a demand, which will be a combination of the structure dead load, live load, and soil overburden if the foundation is buried below grade. In our case, there won't be a overburden because there's no soil that is above the foundation, unless you do bury it beneath. And then the soil provides a supply, which is the sufficient shear strength to maintain its structure with minimum compression and no shear failure. In the basic course, we took 2 steps toward identifying bearing demand. First, we looked at the force applied on the foundation. Then we adjusted this force for the fact that it is not applied directly over the center of gravity of the foundation and eccentric loading. Because of this, it creates a pressure distribution. And we want to make sure that first, there is no negative pressure, which would imply uplifting of the foundation from this eccentric load. And to do this, we check that B star is in the middle third of the footing. So here's that check for you. I've written out in blue. And second, we want to check the maximum pressure does not exceed the bearing capacity of the soil. To do this, we'll use the Meyerhof equivalent width method. This won't be covered again, and all of the formulas are in the bridge binder, but this is just a reminder from the basic design course so that we can set our scene for how we're going to calculate bearing capacity. And this is how we find that maximum bearing demand on the soil. But how do we find the available supply from the soil, or the bearing capacity? This is a very complex subject that no shortage of PhD theses have been written on. And in the following videos, we're going to break down how to find this value from a theoretical perspective that should always be checked and compared with a measurement in the field if that is available.